Hello everyone, Dr. Polaris here. Pterosaurs are among the most iconic extinct Mesozoic animals, even if they are often overshadowed by and mistaken for non-avian dinosaurs. Indeed, only a few species have been widely depicted in popular culture, notably Pteranodon, big asdarchids like Quetzalcoatlus, and the smaller late Jurassic Rhamphorhynchus. However, this group of flying reptiles were highly diverse and inhabited all kinds of niches over the course of their roughly 160 million year history. In terms of size, the smallest pterosaurs could sit in the palm of your hand, while the largest were as big as giraffes when standing on the ground, being by far the most massive flying animals to ever exist. Some groups, such as the strange and adorable Neuronathids, were specialised nightjar or bat-like insectivores, while pteranodontoids were soaring, ocean-going beasts, and asdarchids were largely terrestrial hunters of small prey, similar to enormous storks or ground hornbills. Originating in the late Triassic about 228 million years ago, pterosaurs were the first vertebrate animals to develop powered flight. Despite often being mistaken for dinosaurs, pterosaurs can more accurately be described as close cousins of dinosaurs, with both groups being ornithodira and archosaurs. Until recently, it was uncertain which Triassic archosaurs were the closest relatives of pterosaurs. However, as I covered in an older video a few months ago, it has now been well established that the small agile Lagurpatids were basal members of Pterosauramorpha. One genus of these in particular, Venetoraptor, even possessed moderately elongated fourth digits on the forelimbs, which is also a characteristic of pterosaurs as well, albeit far more exaggerated. It's possible that Venetoraptor was a capable climber, with a 2025 study by Garcia and Muller suggesting that this genus was the sister taxon to Pterosauria. Given that the earliest pterosaurs were also good climbers, this might indicate that these animals developed their adaptations for flight in an arboreal setting, moving from gliding like modern flying squirrels to full-powered flapping flight. However, like bats, we currently lack any direct transitional forms that may shed light on this process, which is not surprising given that these were small, lightly built, forest-dwelling animals. When the first true pterosaurs make their appearance in the fossil record, during the Carnian stage of the late Triassic, they are already heavily adapted for powered flight. Pterosauria as a clade is united by several important and very distinctive features, with the most iconic being the possession of an extremely elongated fourth finger on the hands, to which is attached a set of wings formed by a membrane of skin, muscle and other tissues, stretching down to the ankles in some cases. There has been considerable debate among paleontologists about whether the main wing membranes, or brachiopatagia, attach to the hind limbs, and if so, where. Fossils of the genus Sordes, the Neuronathid Geholopterus, and a pterodactyloid from the Santana Formation seem to demonstrate that the wing membranes did detach to the hind limbs, at least in some species. However, modern bats and flying squirrels show considerable variation in the extent of their wing membranes, and it's possible that, like these groups, different species of pterosaur had different wing layouts. The humerus or upper arm bone was short but powerfully muscled, sporting a large deltopectoral crest which supported the major flight muscles. Due to this wing structure, the wrists were still capable of being pronated, allowing pterosaurs to walk on all fours when on the ground. Their feet were plantigrade, like those of humans and bears, with some groups being highly terrestrial, being able to walk and run effectively. A bone unique to pterosaurs, known as the pteroid, connected to the wrist and helped to support the forward membrane, or propatagium, between the wrist and shoulder. Like birds, pterosaurs possess lightly built hollow bones, as well as a system of respiratory air sacs present throughout the body, which provided very efficient unidirectional airflow to support their active endothermic metabolisms. Pterosaurs sported coats of hair-like filaments known as pycnofibers, which covered their bodies and parts of their wings. Pycnofibers grew in several different forms, from simple filaments to branching down-like feathers. These may be homologous to the feathers found in both avian and some non-avian dinosaurs, indicating that such insulation evolved in the common ancestor of pterosaurs and dinosaurs. In fact, I'm almost 100% convinced that Lagurpatids would have had soft fuzzy coats, given how small and active they would have been. Pterosaurs also had quite large skulls in relation to their body size, which is quite different from most birds and bats, the other groups of flying vertebrates. In some cases, fossilised keratinous beak tissue has been preserved, though in toothed forms, the beak is small and restricted to the jaw tips and does not involve the teeth. Some derived forms were completely toothless, such as the pteranodontids and asdarchids, and had larger, more extensive bird-like beaks. Their brains were quite large by the standards of sauropsid reptiles, with proportionally massive flocculi that handled a huge amount of sensory information related to the demands of flight. Like many other archosaurs, pterosaurs laid soft-shelled eggs with a leathery outer layer, burying their clutch in sediment and not building bird-like nests, as has sometimes been depicted in popular culture. The hatchlings of all species were tiny, regardless of the overall size of the adults, with it being conjectured that the majority of these youngsters would have been highly precocial, able to fly soon after hatching and receiving little parental care. However, some recent studies have found that while ancestrally highly precocial, large-bodied pterosaurs may have produced more altricial hatchlings, which might have relaxed the constraints of small adult body sizes seen in more basal members of the group, allowing these animals to attain much greater proportions. The most basal pterosaurs from the late Triassic have sometimes been grouped together into the clade Eoterosauria, although this has not been accepted by all paleontologists. Many early pterosaurs have been found in and around the Alps in Central Europe, including the small basal Priondactylus, which was native to Carnian or Norian northern Italy between 217 and 214 million years ago, and possessed a wingspan of up to 1.5 metres or 4.9 feet, although the holotype was only about a third of this size, with pointed heterodont teeth, a feature that many basal pterosaurs had that was lost as the group evolved. Priondactylus probably hunted both fish and insects, being a capable flyer despite its comparatively short wings. It also had a relatively long tail that probably terminated in a kite-shaped tip, similar to other basal members of the clade. It was a close relative of the similar Ostreodactylus, unsurprisingly native to Austria about 215 million years ago. Even at this early stage in their evolution, pterosaurs were already experimenting with head ornamentation, as Ostreodactylus possessed a low crest running above the jaws. The basal pterosaur that always comes to my mind is the genus Patinosaurus, as it was featured in the first episode of the original Walking with Dinosaurs, albeit shown living in Arizona rather than Italy. This was the smallest of the early pterosaurs, with a wingspan of roughly 60 centimetres or 24 inches, although all known specimens appear to have been subadults. It probably hunted insects on the wing, and was also a capable climber. Another slightly more derived Italian genus was the fish-eating Eudimorphodon, which possessed multi-cusped teeth, a rare feature among early pterosaurs, with wear patterns indicating this animal was able to crush and chew its food. In addition to fish, it probably also fed on hard-shelled invertebrates. In a similar place in pterosaur phylogeny were the more famous Dimorphodontids, thanks in large part to the genus Dimorphodon, which was among the first of these animals to be found in the UK, and was found by Mary Anning, but scientifically described by William Buckland. Although Dimorphodon itself was an early Jurassic European genus, more recent finds in the 2010s have shown that the family originated during the late Triassic, with the North American Celestiventus, with a surprisingly pleasant name meaning heavenly wind. This was the largest Triassic pterosaur so far known, with a wingspan of up to 1.5 metres or 4.9 feet. Like Dimorphodon, it possessed a large boxy skull with a prominent deep snout, giving the animal a somewhat Roman-nosed appearance. It inhabited what is now Utah, with the holotype recovered from the Saints and Sinners quarry and dated to circa 208 million years ago. At the time in which Celestiventus lived, this was a harsh desert region, indicating that even early pterosaurs were highly adaptable and capable of living in a wide range of environments. It is the only record of a desert-dwelling non-pterodactyloid pterosaur, and predates all known desert pterosaurs by more than 65 million years. Its teeth show that this animal was an opportunistic carnivore, feeding on small vertebrates as well as insects. Meanwhile, its famous close relative Dimorphodon was similar in size and appearance. Originally depicted as a somewhat puffin-like seabird analogue, recent studies show that this animal was actually a rather poor flyer. Its wings are proportionally short in relation to the body, and its skeleton was rather robust. In life, Dimorphodon was probably a burst flyer, in the same manner as modern fowl, tinamous and woodpeckers, being unable to fly for long distances, and probably only taking to the air as a last resort. Its derived position among early pterosaurs implies that this was a novel trait, not an ancestral characteristic, as more basal pterosaurs like Priondactylus were capable flyers. Like most non-pterodactyloid pterosaurs, Dimorphodon was a good climber, possessing proportionally large and curved unguals and a low centre of gravity. Like modern squirrels, it probably moved in a bounding manner as it climbed, although the genus would have spent much of its time on the ground. Analysis of the teeth has shown that Dimorphodon was a hunter of small vertebrates, with its jaws being relatively weak, but capable of snapping shut extremely quickly. Going into the Jurassic, pterosaurs would continue to diversify, producing the successful clade Celestidracones, which contained the widespread rhamphorhynchids and the monophenestratans, which would give rise to the first truly large flying reptiles in the form of the Cretaceous pterodactyloids and asdarchoids. Thanks for watching, everyone. The next episode will be covering some of the most mysterious and controversial tetrapod groups in the fossil record, ones that paleontologists love to argue over, including the mammalian Gondwanatheres and their potential close relatives, the Haramyodons, the lepospondal quote-unquote amphibians, as well as several dinosaur groups, including the Megaraptorans and the mysterious genus Deltadromeus. As I covered it in the Spinosaurid episode, the notorious and plenty controversial genus Spinosaurus won't be making a comeback in this episode though. See you again soon. Cheerio.